Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. Today I'll be doing another screencast on the reciprocal system, specifically on the reciprocal system Macrocosmos database, moons. We've already covered the universe as a whole, galaxy clusters and groups, galaxies, star clusters, stars, planets. Now we're going to tackle the moon, or moons, I should say. I have the display here. I'll just go back for a moment. You can click here for moons, and of course you can, if you were in the planets, you could actually just jump. So let's say I go back to Earth. Here's the moon here. I could just jump to there. Okay, so several different ways to get to the layout for moons. Now, I didn't put in every single moon out there for the solar system. I put in the major ones. You can add whatever you like, however, just by clicking New up here. So let's go through the fields on the layout. We have, of course, the moon name. We have any alternate name, in this case, Luna. And the form number is 1. If you want to put in different information from a different textbook or reference book or authority, you could make a duplicate of the record and then just up the form number and then put in the different data. I've tried to use the most authoritative data for the database, but it's kind of amazing that there are differences in the different sources, so just keep that in mind. And like the other layouts, we have here videos or photos here. Many of these come from NASA. These are in the public domain, videos or pictures. And then we have various events. Now you can I just want to scroll down here just to show you how many different photos or videos I have in here. And then we'll stop and see. I'm only on the seas right now. So let's see. Driving on the moon. Let's go to this one. Click event. And here we are. And there's the rover on the moon. Apollo 15, etc. And then you just click back on moons and you go right back to where you were. So there are thousands and thousands of pictures and videos in this database. Okay, jumping over to here, we have the luminosity, small mv, and the albedo, so it's minus 12.74. That's pretty bright. Remember, negative numbers are higher. This is apparent visual magnitude. The albedo is 0.139 here. I think if I can see that right, or 0. What do I say here in the thing? Yeah, geometric albedo, okay. It's no stellar flux here. I don't have the data for that. And then the UV or BV reddening are here. Then, of course, equatorial radius, polar radius, and the mean radius. These are in centimeters, more or less for convenience. Temperatures don't have the black body, but we do have the mean surface temperature. This isn't Kelvin, by the way, so 220. There's no atmosphere, so that doesn't matter. Distance from the Earth is, of course, 0. It'd be a tiny fraction of 1 astronomical unit. Now, then we have these different numbers here. So we have the diameter in arc seconds here. And then we have, let's see what this one is. This is in terms of the associated planet OIC. Relative to the planet Earth, the mean radius is 0.27270. And relative, this is in terms of Earth's moon unit, so this would, of course, be 1. And then we have the radius in centimeters, and we have, that would be the mean radius here. And then we have the surface area relative to the associated planet and relative to itself, so it's 1. This is all in centimeters squared here. And then, of course, you have the volume measurements here. The orbital parameters, semi-major axis, eccentricity, apoapsis, kilometers, periapsis. Okay, not used to that, these particular terms, but they're calculated. Inclination in degrees, sidereal period in days, synodic period in days. And again, I explain these fields with these tooltips. So just read the tooltips if you don't understand the terms. And then the mean velocity in kilometers per second, 1.022 kilometers per second. Rotation, the tilt degree is here. Rotation period in days, 27.32. Angular velocity, 2.661 times 10⁻⁶ per second. Moment of inertia is here. I'm not going to read it. Rotational energy is here in ergs, and then this is in joules. And then the angular momentum. And then we have the mass in terms of the planet Earth. That's pretty interesting. 0.012. Let's see if I have a tooltip. I guess it's understood. And of course, relative to the moon, it would be 1. In grams, 7.342 times 10 to the 25th grams is the mass of the moon. Gravitational limits, 43.76. So that's kind of interesting. As small as the moon is, I mean, relative to many objects, the first gravitational limit is 43.76 astronomical units. That's of course, the mean distance of the Earth from the Sun. The second gravitational limit is at, let's see, 162,124.65 astronomical units. So that's where gravitation is ended, and a body out there would move at the speed of light if it were not under the control of any other mass. Magnetic field is here in Gauss. Then we have the main density, 3.34 grams per centimeter cubed. This one is relative to the density of the associated planet, and this is relative to our own moon, so it's 1 for that. Geological action, not activity, it's currently none. In the past, yes. There are craters. It is tidally locked, and ice content relatively low. But there is actually some water on the moon, incidentally. Surface gravity is here in centimeters per second squared. Escape velocity is here. And then we have the solid interior contents. You can see it's mostly silicon dioxide and so on and so forth. They give the whole list here. Any iron on the surface is due to asteroid impacts. Some water ice has been found on the poles, like I said. It's practically a vacuum as far as the atmosphere is concerned there. I include a lot of quotes from Dewey B. Larson from the Universe of Motion for each of the different types of objects. So here's a quote from the Universe of Motion relative to or about moons. So I say here, the verdict with respect to the distant satellites, like that with respect to the distant planets, is favorable. I'm just going to go to the theory, but not conclusive. The available evidence is consistent with the theory that the inner cores of these satellites, as well as their outer regions, are composed of substance A, which is the lighter elements from the supernova explosion. But it does not definitely exclude other possibilities. The satellite that we know best, like the planet that we know best, gives us an unequivocal answer. The moon is definitely composed of materials similar to the stony meteorites and the Earth's crust. That is, it is practically pure substance A, as it theoretically should be. Okay, that's it. Really the same quote here. All right, so and here's the associated planet. So if you actually click here, you'll go back to the Earth. There we are. And we want to go back to the moon again. We click here, back to the moon. And I have a total of 65 moons. I mean, there are lots more, but I put in the major ones. So I'm just going to show all. So and then I'm going to, here's Phobos, Deimos, Io, Europa, etc. And as I said, you can add whatever you like. All right, so that wraps it up for today. I'm going to close out. Please study the reciprocal system and prove it for yourself. The simplest possible treatment is my work, The Unmysterious Universe, available from Amazon.com and transpowercorp.com. It has all the concepts. It has many diagrams. It's really an easy read. It's a short book. But if you do want all the mathematics, then please obtain my magnum opus, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. 711 pages in the PDF, 711 slides in the PowerPoint file. Thousands of equations, tables, figures, drawings, you name it, it's in there. It'll take you months to go through with it. Then after that, you could consider getting the 2 database modules. Here we have the Macrocosmos database. And as I said at the beginning, this covers the universe as a whole, galaxy clusters and groups, galaxies, star clusters, stars, planets, moons, minor bodies, nebulae, gas and dust, and voids. And it also contains some graphing programs here. The other module is the Reciprocal System Microcosmos database. So this covers solid matter properties like interatomic distance, valence, specific heat, energy and entropy, thermal expansion, compressibility, electrical and magnetic properties, isotopes, and spectra, atomic spectra specifically. Liquid vapor and gas matter properties, volume and density, specific heat, energy and entropy, viscosity and surface tension, electrical and thermal conductivity. And of course, it also covers the cosmic elements, which are mostly what the conventional theorists call mesons, and it covers material and cosmic subatomic particles, and of course it covers photon properties. Now, my theoretical physics mentor, W. Larson, was also a or was, I should say, a theoretical economist, and I've made his work in economics completely computational with optimal economist and implementation of Larsonian econophysics. So this covers both microeconomics and macroeconomics. Microeconomics of individuals, businesses, and business sectors, and macroeconomics of entire regions and countries. Completely debunks Keynesian economics. There are detailed equations, and it's written in FileMaker just like these 2 physical science database modules. Okay, that wraps it up for today. Please study the reciprocal system and prove it for yourself, and thanks for your attention.